Hello, and welcome to Njeri's Information Channel. So today, we'll be learning about Archimedes Principle. So first, who is Archimedes? Archimedes was born in Syracuse, Italy, and died in 212 BC. He was an ancient Greek mathematician. He was also good in the following fields: physics, engineering, astronomy, and invention. He is most famous for discovering the law of hydrostatics, sometimes known as Archimedes' Principle, stating that the buoyant force on an object is equal to the weight of the fluid displaced by an object. So first, what is buoyancy? Buoyancy is the ability of a fluid to exert an upward force on an object placed in it. Buoyancy results in the apparent loss of weight of an object in the fluid. Every object in the fluid experiences buoyancy. For example, we have a cup of water here and a ball. So I'm going to put the ball in the water. So, the force acting on top of the ball is greater than the forces acting on the bottom. So, the ball floats in the cup of water. When an object is submerged in the water, it exerts an upward force on the object, making it easier to lift. When you push down on the ball, you can actually feel the upward force pushing against your fingers. This upward force, which acts in the opposite direction of gravity, is called buoyant force. That's why when you're in a pool, you're lighter in the water than in air because there's an upward force pushing up against you. When an object floats on the surface of a fluid, it does not displace its entire volume, but it displaces a volume equal to the volume of the part of the object that is submerged. So, as you can see, this part of the ball is submerged, and that volume is equal to the displacement. Now, we will talk about suspending, sinking, and floating. But first, we have to talk about density. Density is the ratio of an object's mass to its volume. Density is expressed in grams per centimeters cubed. If an object is less dense than the fluid it is in, it will float. If the object is more dense than the fluid that it's in, it will sink. Different fluids can also float and sink in one another. So, I will be showing you guys an example. Here is some water, as you can see, and then here is some oil. So I'll be pouring the oil into the water, and let's see what happens. So if we wait a couple of seconds, can you see? It's pretty hard to tell. But up here, that's the oil, and down here, that's the water. So, as you can tell, oil is less dense than water, and that's why it does not mix when you pour it in one another. So, two forces act on every object in a fluid: weight and buoyant force. The force of gravity equal to the object's weight acts downward on the object. The buoyant force equals to the weight of the volume of the displaced fluids. So, when you have the ball, then here's the empty cup. I'll be tilting it like this, and then have the ball here. And then, let's see, when we push the ball down, let's see what the displaced fluids are. So, as you can see, when you push the ball down in the water rises and overflows over the cup. Then, it leaves some displaced fluids, and the displaced fluids are the buoyant force. Okay, when the buoyant force is equal to the weight, an object floats it and is suspended. When the buoyant force is less than the weight, then the object sinks. And when the buoyant force is more than the object, then the water spills out the cup. So, now we will move on to suspension. When an object has the same density as the fluid, then it can float at any level of the fluid. So, when it's suspended, it's not floating or sinking. Submarines are a great example of suspension. They suspend because they are able to adjust the density of the submarine. Now we will talk about floating. You probably wonder how a big steel ship floats in a density of 1. Well, because it's all about the shape of the ship's hull. The hull is shaped so it displaces a large volume of water, creating a larger buoyant force. The ship hull is larger enough to help the ship float in the water. However, if the hull gets damaged, the water will begin to flow inside the hull. The ship displaces less and the buoyant force decreases, which means the ship will eventually sink. Thank you for listening about information on Archimedes Principle. I hope you learned a lot and I hope you share it with others. Thank you. Bye.